In today's video, I'm going to talk about what dark matter is, why we think there's dark matter, and what's next. Dark matter started out as a vague guess to describe some observations that didn't make a lot of sense. In the 1970s, a couple of astronomers, Vera Rubin and W. Kent Ford, were looking at spiral galaxies. And the Milky Way, our own galaxy, is a spiral galaxy, and there's several others, there's lots of others in the universe. And what they noticed is these galaxies, these spiral galaxies, were spinning like a pinwheel. And this didn't make sense based on our understanding of gravity. So if you take all of the mass in our own solar system, it's pretty much all in the sun. 99.8% of the mass of our entire solar system is packed into the sun. So all the planets combined make up well less than 1% of the mass of our solar system. And in a body like that, our understanding of gravity says the further you get away from that massive object, the longer it takes you to orbit. So our expectation with a galaxy like this is similarly, most of the mass is concentrated into a dense center of the galaxy. There's a supermassive black hole at the center of the galaxy, as well as a lot of stars clustered in the center. So our expectation, based on our understanding of gravity, is that stars near the outer portions, these outer arms, should be orbiting much, much, much more slowly than stars closer to the center of the galaxy. So when we observe this pinwheel motion, that doesn't fit with our understanding of gravity. Sure, it's possible we don't understand how gravity works. That's a possibility, and scientists still consider that as an option. Another option is that this galaxy is surrounded by a cloud, a much larger cloud of mass, or missing mass. So you could almost imagine if I took this spiral galaxy and put it inside this volleyball. So then you've got a lot more mass, and that would explain why this galaxy is rotating in the way it is if it's trapped in this much more massive object, that gives this galaxy the ability to rotate in the way that we're seeing. Also, if you trap it in a much larger mass that we're just going to call dark matter for now, it would explain why the galaxy is rotating so fast. Because one thing we're also noticing is these galaxies rotated much more quickly than we would expect based on the observable mass that we can see and our understanding of gravity. And it turns out that someone had come up with this idea in the 1930s. Fritz Zwicky in 1933 was looking at multiple galaxies. He didn't quite have the telescopes they had in the 1970s, but he could at least see galaxies. And he noticed that these galaxy clusters, and that's just a cluster of galaxies close together, they were moving far too fast. So according to our understanding of gravity at that time, these galaxies should have just broken out of each other's gravity connection. So the speed with which these galaxy clusters were moving didn't make sense, so Fritz Zwicky coined the term dark matter or missing mass. And he basically said there must be a lot of mass that we can't see, and that's why these galaxies are held together. So another way that we can assume there's a bunch of missing mass or dark matter is if we take a galaxy, and we'll just take the spiral galaxies that we looked at, that's a spiral galaxy there, and then we're looking at it. This is an eyeball. So here we are on Earth, and we're looking at this galaxy far away, so we see it, we see it directly. But it turns out, if there's a galaxy behind, and I'm going to draw a different type of galaxy. So this is a bar galaxy. So we have galaxies that look like spirals and galaxies that look like bars. So this galaxy, we wouldn't be able to see it through this galaxy, but what happens is very interesting. Light comes off this galaxy, and this galaxy, the spiral galaxy, is so massive it actually bends the light. So then we see this bar galaxy. But you'll notice the light can go around in this direction too. And we'd actually see a second identical, it's the same galaxy we're seeing, but we're seeing it in two different spots in our eye. We'd actually see it all around the object. This is called gravitational lensing. So using gravitational lensing, we can get information how massive must this galaxy, this spiral galaxy be to be bending light so that we're seeing two identical galaxies at different spots in the sky. How massive must this be? And it turns out that it must be a lot more massive, because instead of seeing these pathways, we're seeing much starker pathways. And we're not seeing these pathways here. So let me just erase this. So the explanation for us to see this galaxy lensed in the way it is that there must be a lot more mass to this galaxy than we're seeing. So there's a bunch of missing mass or dark matter. So those are the three common ways that we're seeing, the three common observations where we think there must be a lot of missing mass, and I mean a lot. So according to these observations, there must be more than 10 times as much of this dark matter stuff than there is of the regular matter that we can actually see. Again, it could turn out we don't understand gravity, and gravity works very differently, but there's a lot of evidence that really supports this. And there are galaxies that we see that behave exactly as we expect. And so we've discovered at least 20 galaxies now with almost no dark matter. So there are places where just matter that we visibly see makes up the entire galaxy. And there's also galaxies we've discovered that must be made up of almost entirely dark matter, like over 99% dark matter, because it's so few stars moving so fast that they couldn't be gravitationally bound to each other unless there was a bunch of mass we couldn't see. So what's next? Since the 1970s, particle physicists have been looking for dark matter. And they haven't found dark matter yet, as of early 2021. But that could change any day. So any day, particle physicists could come along and say, hey, we've discovered dark matter. What excites me about the search for dark matter is that for every question we answer, it's likely we're going to have 10 more questions. So if dark matter makes up more than 10 times as much of the universe as regular matter does, which is what we see gravitationally, then what's the likelihood that it's all made up of just one type of particle? And my guess is it's made up of a lot of different stuff. And maybe we don't understand gravity. Maybe gravity changes with time and distance and space. So it's certainly possible that dark matter is part of the answer and our understanding of gravity is part of the answer. They're not mutually exclusive events. It's not an either or, it could be an and. And that's what I love about science, is for every question we answer, we often uncover more questions. If you enjoyed today's video, please hit that like button. It really helps me understand the content people are interested in. Comments are always helpful. Hit the subscribe if you're interested in all of my videos. And a special shout out to Heather LaMonica Deckard for inspiring me to make this video when she asked me my thoughts on dark matter. Thank you very much.